Today we will learn Sutherland Hodge polygon clipping algorithm. A polygon boundary is processed with a line clipper may be displayed as a series of unconnected line segments. If we want to clip a polygon using line clipper, then we get a series of unconnected line segments. We can't get any closed area like this. For polygon clipping, we require an algorithm that will generate one or more closed areas. The output of a polygon clipper should be sequence of vertices that defines the clipped polygon boundary. So the output should be this, but using line clipper, we can't get any closed area, we get some series of unconnected line segments. So we have to learn polygon clipping algorithm. So in case of Sutherland Hodge polygon clipping algorithm, for clipping a polygon, we have to process the polygon boundary as a whole against each window edge. Beginning with the initial set of polygon vertices, we first clip the polygon against the left rectangle boundary to produce a new sequence of vertices. The new set of vertices could then be successively passed to a right boundary clipper, a bottom boundary clipper, and a top boundary clipper. At each step, a new sequence of output vertices is generated and passed to the next window boundary clipper. So what is Sutherland Hodge polygon clipping algorithm? There are four possible cases when processing vertices in sequence around the perimeter of a polygon. Case 1. First case is if the first vertex is outside the window boundary and second is inside the window boundary. Then both the intersection point of the polygon edge with the window boundary and the second vertex are added to the output vertex. Save the intersection point and the second vertex. Case 2. If both input vertices are inside the window boundary, then only you have to save the second vertex. If first vertex is inside the window boundary and second vertex is outside, then only the edge intersection point with the window boundary is added. Only save the intersection point. Save V1 dash. And the last case, if both input vertices are outside the window boundary, nothing is to be saved. Save nothing. Now take one example. See, this is our polygon. I want to clip this polygon using Sutherland Hodge polygon clipping algorithm. Now see, first 1 to 2, first vertex outside, second vertex inside. If first vertex outside, second vertex inside, save the intersection point and the second vertex. So save 1 dash and 2 dash. Now from 2 to 3, both point are inside. So from 2 to 3, if both are inside of the clip window, then you have to save what? You have to only save the second vertex. Here also 3 to 4, both are inside, save the second vertex. This is 4 dash. Now from inside to outside, first vertex is inside, second vertex is outside, then save only the intersection point. This is 5 dash. Now from 5 to 6, first vertex is outside the window boundary, second is inside the window boundary, then save the intersection point and inside vertex. This one is 6 and this one is 7 dash. And if the first vertex is inside and second one is outside, then save only the intersection point. So we get the saved point 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash and 8 dash. So the final, after clipping, finally we get this polygon. So this is our Sutherland Hodge polygon clipping algorithm. Now this is your assignment 3. Go through all this problem and try to solve this problem. Pause your video, try to solve this problem and feel free to ask any question. That's all for today. Thank you.